So as you will have just heard that this session is being recorded, I'll come to that in a second, but good afternoon everyone, and thank you, as I say, for joining today's session. I'm Sean Gibb, I'm the Events and Marketing Manager at Pro Manchester, and I'm delighted to welcome you to Decoding the Industry, BEMS. What is it, and what are the common pitfalls costing you money, hosted by Thermatic Energy Services. Following today's session, I'll send out a post-event email, which will contain any post-event collateral. There'll be some links to the Thermatic Energy Services website and some contact details for you to find out more. It'll also include our post-event feedback form. So if you could take just 2 minutes to fill it in, it's only a really short form, but there's a couple of key questions on there that just really help us to consistently provide great content. And there'll also be a link to our YouTube channel. Just a couple of points of housekeeping. Please be aware that this webinar is being recorded, and feel free to use the chat function to ask any questions, make any comments, observations, and I'll help address those towards the end. And then if you just keep your microphones on mute. So without further ado, I will introduce you to Jen Johnson, Managing Director of Thermatic Energy Services, and Dean Walsh, Head of Thermatic Energy Centre.
Hi everybody, thank you for joining us today. We are doing a couple of these Decoding the Industry webinars and sessions, and the aim of that is to kind of shine a bit more of a light onto areas that perhaps people don't fully understand. We have a lot of kind of high level clients that are making decisions about their buildings, not perhaps understanding exactly what they've got, and obviously going through that, it does help and kind of puts things in a little bit more context about what things can do, what things could do, and going from there. So yeah, thank you very much for joining us today. As Sean said, I'm Jen Johnson, Managing Director of Thermatic Energy Services, and we've got Dean Walsh here. Dean.
Hi there, everybody. Yes, just thanks for that, Jen. Yeah, my name's Dean Walsh. I'm head of the tech, or AKA what you might call the in-house geek, should I say, or BMS enthusiast, as I like to be called, would be nice. But yeah, no, thanks for that, Jen. Yeah.
So moving on, our aim here is to kind of cover two areas. So one, kind of what is it we're actually talking about, and then actually go into some of the common pitfalls. BEMS, BEMS, BMS, it's a huge area, and we couldn't start to cover all of that. So we've really picked some kind of summary things that hopefully will start to paint a bit of the picture. So starting us off, what is a BEMS, a BEMS, a BMS? So we've got a short little video by one of our partners who we work with, Tridium, that we'd just like to share just to kind of get that high level message across.
Every machine generates and transmits data. It's like they're talking all the time. The problem is they all speak a different language. To really make use of all that information, machines need to communicate to each other and to you. Machines talking to machines is the defining characteristic of any system of systems. Like a building, for example. In a building, you want airflow and temperature control systems from different makers talking to each other in the interest of making occupants comfortable and preventing energy waste. These goals are even better served when energy metering, lighting, backup power, fire and smoke detection, and access control are brought into the loop, and you don't want to leave people out of the conversation. Building operators, occupants, CFOs, and even the systems engineers and technicians who design the building want to know.
So that just gives you kind of a very
intended.
high level idea of actually kind of what the BMS is and what that could look like. And there's just a couple of points that Dean's going to actually just run through on the back of that, just to do some more clarification. Dean?
Oh yeah, sorry, Jen. Sorry, mate. I thought we were watching the rest of that video. I got to get drawn into that a little bit. Yeah, so with your building management systems, what is BMS? What does it stand for? A lot of people call them BMS. Some people call them BEMS. So, but genuinely, the idea of the name of it is that it's a building energy management system. That's what's going to monitor and control your building and all your services. So that could be anything from your air handling units on your roof, your AC units on your office floors, your HVAC system in general. And And what this is your central brain. This is what's, connecting to all of your services. And this is what's basically going to be making decisions on what to do. And this is used to then manage your temperature environments, reduce your energy consumption. And then obviously we also need these systems to tell us when things have gone wrong as well. So that's just a bit of a brief idea there of what an actual BMS system is and what it's connecting to. But yeah, so BMS, Building Management Energy Systems.
So one of the things that we often talk about, and and Dean and I are out with clients as well, is that the BMS is a bit like a computer that sits in the middle of a building and kind of pulls information in and out. So what we're going to do is just go into actually how that function works a little bit more clearly, and go through a bit of a breakdown of the different components. As you can see on the right in our video, there's been a couple of items that we've actually robbed from various places in the office, but Dean's going to just give you a little bit more of a rundown about what these are, if you see them, what their role is in your BEMS system.
So the actual breakdown of the components that we've got is starting really with your supervisor. Some people refer to them as supervisors, some people refer to them as head ends, front ends, but genuinely they're pretty much the same thing. That is your window into your system. That is your visualization of what you use as a user to be able to connect and see what's going on in your system. And that's where you'll tend to find a lot of your alarm management will come back to, your metering data will be displayed on. And then obviously, most of the time, you'll find that there's quite a graphical representation of your HVAC system or your boilers or what it is that you've actually got connected to your system. Supervisors and head ends, ideally, they could just be a single system on its own. It could be a cloud hosted one. So say if you've got 50 sites or 100 sites, or even, to be honest, even if you've got a couple of sites, you can still host that clouded. On a cloud-based format. But sometimes we've seen these systems, Jen, like I know you've seen them before and I've seen them, and then we've gone to a site and gone, have you got a supervisor, you got a head end? And like, well, I don't know, I think we have. And then eventually you'll find that it's been tucked away at the bottom of a panel, getting dusty. And then you open up the panel door, you think, oh, there it is, poor little guy, let's get him out, get him displayed. But yeah, so the supervisor, that's your first point of call. Supervisor, it might not necessarily be a PC that you're using. It could, in theory, be a little touchscreen that's mounted onto the front of a panel door that's just beeping away and people walk past it and not really know what it is. But the supervisor is a bit more of a higher level one. So if you've got a big building, more than likely you would have a supervisor to start off with.
We were actually working with a client a month or so ago, and we went and had an initial chat. I think we were looking at about 30 or 40 buildings, but we wanted to get a feel for them. And Dean and I were on site, and we were chatting to the general manager for the site, and they said, no, we don't have anything like that. We don't have that on site. And actually, I think, Dean, you'll have to correct me if I'm wrong here, that the issue was actually it was sat on a server, and that they were just kind of linking into the supervisor. So there wasn't a physical PC somewhere they could call that head end. It was just a link that they had that communicated back to a server where that software was actually saved. And they'd lost the link, and that was it. And they actually were potentially going to pay to get that supervisor set back up. Well, it was hiding away there in the background. Am I right, Dean, with that?
Yeah, absolutely spot on. Yeah, it was like some supervisors, like some of the old school ones, was like a really big bit of software that was installed on a front end PC, so you couldn't really mistake it for anything else apart from a supervisor. And to be fair, it's that big and clunky, you're never going to lose it. But what you tend to find with a lot of the newer ones, especially in that scenario you were talking about, Jen, is yes, it was actually using a web page link to bring up the supervisor's front end page, and then you could log into it. And it was just simply that they just lost the link. But luckily, when we were on the site there, and I've worked with a few of these systems in the past before, so I was able to quickly find that link for them and get that back onto them. And they were like, oh, I can't believe this. We've got, we'll be able to log in our system again. We can check what's going on. So it really helped them out. And to be honest, it didn't take that long really to find it, to be fair. But it is easy if you know where you're looking for it. you know, but yeah, that was a good one, actually.
It's always nice to be able to give that kind of like little tweak when you're on site, isn't it? Brilliant. So moving on, we've got then our controllers, and we've got a bit of a smattering of different controllers that again we've kind of collected from our academy on the right there.
Yeah. Now, some of those controllers you may see on there, they may, some of you watching today might actually recognize a few of these, but these aren't the only controllers that are out there. These are just some that, like I said, Jen, we've managed to pinch around from the office. Some of my testing kit that we do here in the academy have used that for. But what you tend to find with most of your controllers is the controller is the real bit in the middle. It's the important part of it. It's the brains. It's what's got sensors connected into it. It's what's got outputs going out from it to control your boilers, your air handling units, or whatever it is that it's connected to. But a lot of these controllers come in loads of different flavors, you know, and loads of different shapes and sizes and colors. But at the end of the day, all BMS controllers are the same. You know, there's going to be slight little differences between them, but ideally, all BMS controllers are the same. It's a brain in the middle that has an input coming in from one side and eventually ending up at an output on the other side. It's just really the strategy that's within inside those brains that comes a little bit different between them and different manufacturers that are out there. But it's a these are very, very important bit, because this is what is going to make that decision of where it's going to turn something on or turn something off.
Brilliant. And then moving on, we've got the different field devices. Now, we did stop Dean from taking apart the academy to get some examples of this. But yeah, here again, there's a sample there, Dean.
So same again, just like the BMS controllers, it's exactly the same with your sensors. You know, your sensors are your eyes and ears of what's going on out there. You know, these are what's detecting temperature, detecting the CO2, detecting light level or air quality. Or you could get a sensor, and most of the modern ones nowadays actually allow multifunction features, which have a lot of those abilities built into one sensor, which is really good. You know, keeping costs down, not that I have to buy one sensor for temperature, one sensor for CO2, you know, and that's where a lot of the IoT industry's really been pushing that. And a lot of the BMS manufacturers have jumped on that as well, to be fair, and actually providing multi-use sensors. But again, yeah, these sensors, these are your eyes and your ears of your system. These are what are telling you what's going on. And again, they come in loads of different shapes and sizes and all sorts. So if you do see a sensor out there on the wall, it might not look like a traditional sensor, these modern ones nowadays. You know, it's not like a big, you know, square thing that's on the wall that's saying, screaming out to you, they're going, I'm a sensor, you know, or anything like that. So yeah, do consider when you're looking for sensors and stuff, you know, have a look around, because it could look like anything now.
I think that's a really common thing for anyone who's worked in the controls industry at all, is that you have like a knack for spotting sensors when you're in a building and then having a quick mosey up to see what's installed and what's there. But it's a good identifier of perhaps how that building's being actually controlled as well. You know, you kind of think, oh, that sensor's in an awful place. Like, how can that be actually reading correctly? And it starts to then think, actually, there's probably big opportunities with this system. So I'm not going to steal Dean's thunder, because he's going to do a piece on that in the coming slides. But yeah, you know, keeping your eyes out when you're on site and having to think about what devices you do have, what is telling your system to run or to operate in a certain way is kind of important to what you actually want to achieve at the end of that.
Or also, Jen, I just wanted to mention that when we talk about field devices, we're not only just saying about sensors. A field device is, when we talk about field devices, that's what's out in the field. That's what's actually in your plant room controlling. So sensors, massive part of that. But it doesn't just end with sensors. So it could also be things like actuators, or could be a contactor, maybe turning a lighting circuit on and off for you. And when I talk about actuators, that's the bit of kit that's actually opening and closing a valve according to if you need more heat going through, let's say, for instance, your radiators, or if it's an air handling unit, it could be opening and closing automatically the cooling coil on your air handling unit. So field devices is a bit of a general term, but it's basically whatever in the field the BMS is connected to.
Brilliant. Thanks, Dean. Communication, like, I'm going to leave this one fully to you, Dean. This is totally your bag.
Yeah. Now we did have this bit in about communication links, because it was just something we wanted to mention there. Is like, I say back in the day, I'm sounding like really old when I say this, but true. Back in the day, when a lot of these BMS systems were out there, and I don't want to name any names about particular manufacturers, but different manufacturers anyway, when they created their systems back in the day, they didn't want their system to talk to another system. They're like, well, why would you do that? Because then they're not going to buy our kit. So back in the day, a lot of these systems were very closed protocol. Only that manufacturer just wanted to connect to their kit, same with the next manufacturer and same with the next manufacturer. Now, the problem is with that is you can't necessarily get everything that you want from the same manufacturer. It might be the fact that these guys over here have got a really, really good product for a really reasonable price, but I can't use it because it's not the same manufacturer as what I've already got. So a little one out there for communication between different systems is a lot of the more modern stuff, even if you've got the old stuff as well, you can adapt now and actually connect those to third-party systems. A lot of the newer systems are coming with this already on board. So it may be physically be able to do it. It could be just something simple as that. Oh, I just need to upgrade my license. And as soon as I've upgraded my license, then that means that I can connect to this type of system now or that type of system. So a lot of the, don't be too discouraged if you do have an older system. There is ability to be able to add these in and add these extra bits on. But what you kind of things is really to ask for from your system is, okay, right, I've got this system. What can I do? Well, what can I communicate to? Sorry. So what you really want to be pushing is asking the questions about open protocol. Now, when we talk about open protocol, what that basically means is that it's let's just say, I'm trying to not be too specific on manufacturers, but let's just say, let's just say, can I say like, yeah, I can say, just say like I don't know, I'll say McDonald's. They say McDonald's and Burger King. Let's just say McDonald's wants to talk to Burger King. They both make burgers, they both make chips, but these guys won't talk to these guys. So basically what you want to be doing there is looking at open protocol communications. Now, most of the common ones you'll come across now are things like Modbus. Modbus has been going for years. Now, Modbus is it's an open protocol. Yeah, it is an open protocol, just like BACnet, MBus, LoRaWAN, and MQTT. Now, these are just some of the ones I've picked out there. BACnet, very common. A lot of the systems out there now are actually engaging with BACnet. Now, BACnet's even going to a slightly higher level, which is a more of secure version, because there was a few issues out there, people thinking that it was a little bit too open. But so they've gone to an extra level now, it's BACnet secure. But what this basically means is it means that all of these systems that you've got in your office or your building, it just means that I can get my AC units to talk dead easily to my BMS. It means I can get my lighting system talking dead easy, my fire alarm system, I can pull that in now as well. And what that does is it just means that I can bring everything together. So instead of me literally, like when I used to do this, well, I say do this, when they used to do this back in the day, they'd walk into a room, a security room, and they'd have literally like 20 like monitor screens all over the walls, one doing the fire alarm, one doing the lighting, one doing the HVAC. So what this means now with open protocol, it means bring it all together. Just bring it all together in a single platform. And it just makes your user experience so much easier. But also it means that you're not limited to a single manufacturer's system. It means I can go and get a different one now and integrate that as well.
No, that's a really good point. And I think as well, when again, we're going to talk a little bit about upgrading and improvements, but when you are looking to improve your site, what am I getting? Is it going to be open protocol? Is it future proofing for me to be able to actually connect this to other devices? Because obviously Dean hasn't wanted to name any names, don't blame him for that. But there are still systems out there that will really try and tie you down to just their system. And even if that kit's the only kit that you're installing on site, it doesn't mean that that's it, project done. You're also going to have to go to them for spares. You're going to have to go to them for, ongoing support, maintenance, call outs. And often the people that you are physically tied to, because they've got these closed down systems, are the people that you're waiting 2 to 3 weeks for an engineer to get there to sort that situation out, because no one else can look at it. And they don't really have to improve that service. Whereas when you're looking at more open protocol systems, there's a lot more people that can work on them, a lot more engineers available, which means you can really challenge the market and get a really good service there for reactive call outs and pricing on repairs and so on. Okay. Common pitfalls. So this is where we've tried to break it up a bit, so you're not just hearing our, well, I say hearing our voices and looking at slides. You will be doing the same thing, but we've tried to mix in a little bit of video content in here as well, just to give you a bit of a change of pace. So first thing that we were going to look at was upgrades. Do you know what you're getting when you are getting an upgrade proposal through, whether you're actually having your systems upgraded at the moment? Do you actually know what you're getting? When you're considering upgrading your BEMS or BMS, whatever you want to call it, you've got to consider all the different levels and how that could actually look on a quote from one of your suppliers. So, we all talk about upgrades and improving the site, creating that resilience. So again, how much of that are you getting within that proposal? Just as a quick run through, so generally you've got your supervisor, your head end, that's how you're actually interacting really with the system. That's where you'll have your graphics, your alarms, potentially, things like that. You've then got your actual controllers. Normally these could be, say, in your plant room or in like a roof plant room or your main plant room. It's got your boilers and your chillers and etc. in. And then you might have additional communication controllers throughout that building. So they might be controlling things like fan coil units on each of the floors, each of which again has its own controller. So if someone's saying to you, oh, I can upgrade it and it's the cheapest price you're sitting, you think brilliant, you could actually be ending up with pretty much just a facelift on that system. So they might just be upgrading the supervisor head end side so it looks shiny and new, but you've got all this kit behind the scenes that isn't actually being upgraded. So again, if you've got failures where you've got hots and colds on the floors, you've got fan coil units that aren't performing, upgrading that isn't going to help what you're actually trying to achieve. It's purely just going to make things look prettier when things go wrong. So again, understanding what you're actually getting in the proposals is really key. We often do hybrid upgrades. So with our clients where they're saying, yes, I have loads of issues with fan coil units, but I don't have the budget to upgrade all of my fan coil unit controllers. There's ways and means around that. We can upgrade the main controllers, we can upgrade the supervisor, but rather than upgrading all of your fan coil unit controllers on your site, we can actually just pick, say, one floor, upgrade those to the most recent controller, so you've got that resilience, and then use those potentially as critical spares for the other floors until you've got a budget to do it. So the main message here is just understand, if you have a proposal in front of you, what does it include? Or more importantly, asking the question, what does this not include within my system? A step further than that is you've got your field devices, so your sensors, your actuators and so on. So again, understanding it, really key. So yeah, the main message there being, we have worked with clients in the past that have had a couple of prices on the table, but they just were not like for like for what they'd actually asked for or what they were trying to achieve. So it's really good if clients have got the confidence to go back and actually challenge that pricing. And if they don't feel they're able to do that, there will be people out there like Thermatic Energy Services where they can come and have that open chat about, what do I want to achieve? What do I then need to do that's going to give me that future proofing? So you can actually really validate these proposals and things when they come through. Another common pitfall is overheating and overcooling. And we've done this based on sensors. And this is Dean talking in our academy, I believe.
Yeah, just where I am right now.
If you're a site or a retail company, should we say, that's got hundreds of sites, most retail environments tend to have quite basic strategies in place, and we'll have units, maybe something like this, where we've got gas-fired units in the ceiling space, or it might just be simply AC units dotted around. But again, sensor locations are absolutely important in this type of environment, especially for the fact that it will cost you a lot of money if you've got these units firing away or cooling down when they don't need to be. So sometimes with these type of sensors, again, in a retail environment, it could be anything that it's been had a retrofitted in the store, the shops had a refit, and maybe these sensors are hidden behind the shelving, the racking. Maybe the electrician found it difficult to wire in the sensor and just put it in the easiest location he could. These are the things that you definitely need to look at in those type of environments, especially when money is a big thing for the retail markets, and you've got to make sure that these are going to be working correctly and controlling the temperature of your space well. So again, sensor locations, really important, keeping them at eye level, keeping them away from fridges, freezers, especially keeping them away from open door entrances, warehouse entrances, and just making sure that they're in a good spot and not being influenced by anything else. Because obviously pennies and pounds cost us, especially when these units are running, but when you don't need to be. So again, guys, keep a lookout in the retail industry for sensor locations.
So just leaving Dean's smiling face on the screen there. This is such a huge topic, and it's normally quite easy to resolve. We had a site out in Liverpool. They were experiencing really high issues. Their help desk was getting loads of calls to say this site was overheating. They couldn't understand it. They were hemorrhaging energy. It was costing them a fortune. And it was just the sensor was in the wrong place. The sensors for the shop floor were in a really drafty area by some doors. So they weren't really representative of what was going on, but they were going, oh, it's freezing in here. Quick, let's put the heating on and keep it on all day and all night because we need it on. And ultimately, just through moving the sensors, and actually, I think we replaced them in the end with wireless sensors. So there wasn't even kind of a huge install cost or anything associated with that. It was, it made a huge difference. We come across it all the time. Sensors above kettle, sensors that have been panelled in, sensors that have been Dean above ceilings when you're kind of looking above what's there, rolled up and just hidden away in like a nicely heated space. And everyone's saying it's freezing. Well, the sensor's not. The sensor's saying it's nice and warm in here. Don't come on. I don't need any cooling. So it's really kind of looking at it, although it sounds like such a basic thing. We talk about this kind of thing at really high levels within businesses because it's so important, yet so simple to actually get resolved.
Absolutely. Yeah, absolutely. Now that video there was me talking a little bit more about the retail industry, but it's exactly the same in any other environment, really. If you're in an office space, like Jen was saying there, above hot kettles, I've seen printers, a new printer, I've gone, and I go, did anything happen about a week ago? They go, well, actually, yeah, we installed a new printer. And then I went over and had a look at it, and the print was right underneath where the sensor is. And I'm not surprised that they're feeling really cold. So yeah, it does sound like a bit of a simple thing, but honestly, guys, I've seen it so many times out there. And it's just definitely really important to make sure you've got those sensor locations right.
Brilliant. Oh, sorry, rushing ahead. Are you overwhelmed by alarms? So, when I kind of first moved into kind of the controls industry, we'd often go out on sites, we'd start at the head end supervisor, and it wasn't uncommon to see like that there was 9,999 alarms sat there unacknowledged. Dean, what's your experience with that?
Oh, yeah, I've seen it so many times. You tend to find like when a new job has been installed, let's say, for instance, a brand new building, there's never really that detailed specification to tell you exactly how your alarms are required to be filtered. They tend to be, does the system provide alarms? And it's just more like a tick. Yes, it does. Now, the problem you'll find with most of these systems, and I'm, again, not naming any particular names, but I've seen it many times when I've gone to a site and the alarms are literally, like Jen said, which are 99999 plus alarms. And these alarms are literally doing everything. These alarms will log in when someone's logged in, when someone's logged out. The time of the day is changed, or it could be anything. Now, if you don't apply filtering to your alarms, then that's why those alarms will eventually get so massive. And then what happens is when those alarms aren't filtered is people then start forgetting about them. They start taking them. It's like the boy who cried wolf. If your BMS system is constantly beeping at you all the time, and eventually go, oh, don't worry, it's just the alarm. Don't worry, forget about it. well, what happens if there actually was a serious alarm in there that you actually needed to do something with? It's just going to get buried away and you're never going to see it again. So definitely, it's so important to make sure you put some prioritization and filtering into your alarms. Just even if it's simple, just keep it 3 levels. Just keep it low, medium, high, and then make sure that your high alarms are the ones that you definitely make sure, and maybe retransmit them somewhere else, or your medium or your lows.
I often find like when we're kind of talking to clients where they want kind of this alarm escalation and they want to be able to know when there are actual problems, and it's always good kind of just having a couple of hours, or not even a couple of hours, half an hour can pretty much iron out what is the most important things to that building, to that estate, to that client. Things around energy alarms, they could be around failures, it could be around temperature conditions and so on. And it doesn't take long to get to what the fundamental problems are. And then all it really takes is that bit of engineering time to actually go through and rationalize those alarms. We've put it down into just a couple of bullets, so why are they reoccurring? So if you've got sheets and sheets and sheets of alarms, you're absolutely inundated. You can often export them and start to look at where you've got repeat alarms that you're constantly getting at certain times in the day, and you can actually start to address them. If you've had the same alarm 900 times, then it's probably not a relevant alarm. If it is, you've got serious issues. But again, that's how I would tend to address that, to actually look at what are my reoccurring alarms? How often are they reoccurring? Are they causing me a lot of traffic? Yes, right. Let's have a look at, is that important? Do we need it?
Mm-hmm.
Are they relevant, or could they be disabled? Again, are they things you need to be told about, or are they things that will just happen to be tracked in the background? So for example, things like you're logging in, you're logging out, and so on. Yeah, you want to keep that, you want that history, that auditability of who's done what and when. But similarly, do you need that big alarm being sent out to everybody when Bob signs in for the day, or when Lucy wants to just quickly log on and check some temperatures? Probably not. Are they being sent out effectively? So how are you actually receiving them? Dean was talking before about, you can have like a little touch screen on the front of your panel, and that's got all your alarms in. Well, that's great if you've got someone perhaps down there staring at it all day, but you probably don't. They might go down every so often, hear a bit of a beeping, going, oh, there must be an alarm on the BMS. I'll have a quick look, and that's that point of investigation. Whereas if you've got your alarms, again, prioritized so you're not all getting hit ridiculously with emails and texts and so on. But if your alarms are actually being issued out to either yourselves, your team, some places have that going through to the reception desk so they can escalate. A lot of our clients have them forwarding through to ourselves so we can do a remote investigation before an engineer goes out. But again, if they're sent to us when they actually happen, we can react, we can make sure that we make a change that's going to improve the site and obviously potentially stop further failures. If nobody knows that alarm's gone off and it's sat there in a whole host of other alarms that aren't important, or it's sat in a plant room beeping away and no one's there, how can that actually be addressed and resolved without somebody going, actually, it's freezing in here, or we've got no hot water, or all the lights have gone off? So yeah, making sure that they're actually being communicated out effectively. There is an element of making sure that when you do have your alarms, actually actioning them and clearing them down. So there's some sort of maintenance there, from a BMS maintenance kind of perspective. I often see where the alarms just get kind of looked at. When there's a main alarm, it'll get kind of addressed, but then they wait for for a maintenance engineer to then turn up and actually do that clear down once or twice a year. Ideally, that's something that you could be doing constantly, just to make sure that you're keeping on top of your alarms and you're not getting to that point again where you've got thousands of alarms that you've got to then wade through. So yeah, it's all about rationalizing the alarms and prioritizing them. So do you need to have 50 different alarms to do with one boiler, or do you need to know that there's an alarm on that boiler so you've got one communication if there is an issue? And prioritizing, as Dean said, making sure that you've got those categories. You can even then build that into your escalation. So for example, you wouldn't want the CEO of the business perhaps knowing that, again, Bob's logged in to check what the temperatures are doing, but he might or she might need to know if there's been a total failure on site. So through the prioritizing element, you can actually make sure that the people who need to know do know, so they can actually start an action and obviously get that issue resolved.
Yeah.
Is your BEMS metering supporting your energy reduction strategy? Right, so this is another one for me. Sorry, I'm going to drone on a little bit longer. We see clients that have got lots of potential in the systems they already have. They just don't know that they have it. You know, clients that are entering into huge metering projects, you know, we need to get all the sub-metering in, we're going to do all this work. And they've already got it, it's already there, it's already connected into their BEMS system. It's just not perhaps visible on the graphics, so they don't realize it might not be logging, it might not be working, they might not even know what the BEMS is and how that operates. They've just been tasked with doing a metering project. You know, we found this a couple of weeks ago with a client, again, we were working with, which is probably why it's on our pitfalls there, because it's quite something we deal with quite a bit. So understanding, again, the BEMS side of it allows you to support other projects and things that are going on and knowing what you've already got. So that money could be spent on actually things that are going to make a difference from an energy perspective, not just the monitoring if it's already there. So some pointers on this, you know, Dean and I were having a good natter before about why metering on the BEMS system is usually kind of a little bit underloved. And it's usually done right at the end of a project. They've been really squeezed on time. They'll have been squeezed by the contractor they're working for, by the client that wanted that project installed. And the metering is kind of like a last frill, or it's seen as a last frill in that project. It's not really seen as like a core requirement. So we often come across issues that actually could quite easily be resolved with that little bit more time at the end of the project. So number one, make sure your data is logging at the right intervals. So if you've got metering coming into your BEMS system and you want to perhaps compare it to your half-hourly utility information, or you want to look at half-hourly data, then make sure it's logging at half an hour intervals. You know, it's not a major thing. A controls engineer will be able to set that up for you and actually make sure that data is coming through, so you can actually profile it and build it into your energy management strategy. Half an hour intervals is also kind of a nice marker for comparing it to other things like temperature data, runtime data on the BEMS, and so on. So again, making sure it's logging and being stored.
Oh, yes, needs to be stored. That's right, because a lot of those, sorry to jump in there, Jen, but yeah, a lot of those BMS systems, you know, those controllers that we talked about earlier on, is they do have internal memory, but they don't have that much memory, especially when it comes to trying to store in data. So what you really need to make sure you're doing that data, like Jen saying, that data is being stored, maybe in an SQL database, maybe just exporting it, saving it as a CSV file. But yeah, make sure you've got it. If you've got it there logging, why not store it? Because historical data is really important to go and see how your building's changed.
Yeah, I think we've probably all been there where we've like logged into a BEMS system. I'm going to name a name, but it's not a bad thing. So like a trend system, and automatically it's only storing the last 1,000 values for that point. And you just want to see the week before when there was a big catastrophic incident on site, and you want to see what the consumption changed and how the temperatures changed and all of that. And you can't, because it's only stored 1,000 values, which is about 10 days worth of data. Is that right, Dean?
Yeah, if it's half hourly, you'll get around about around about 15 days, 15-minute intervals. Yeah, it's probably about right, that, to be honest. Yeah, it's about, so as soon as that 1,000 values comes round, that's it. The BMS controller doesn't care. It's just literally like, boom, I'm just going to start now recording, carrying on now recording, and that data is gone. You lost it. You can't get it back.
Yeah. And I think with that, it's a very simple fix to retain the data. It's just often not done within the platform because it's probably not the sole focus of the installing engineer when they're up against it at the end of that project. Dean mentioned about CSV, looking at how you can extract the data so you can actually start to build it in with bigger plans, bigger pictures. You know, we're all talking about net zero. We want to make sure that we're reducing our carbon. And a lot of that kind of in the strategies and the plans put together comes down to monitoring and metering what you've got. So if you've already got this kind of inbuilt metering monitoring system, it doesn't have to be everything you ever wanted. Anything is going to be a benefit. So being able to pull that data out in a format you can use is really key. There's different ways of doing that. Personally, I've never set that up myself. I know Dean's a lot more experienced. But again, getting that out into CSV, it just means that it's usable and you can actually then kind of merge it in with other data sets. You can work with your consultants around the energy management piece and utilize that data. Then we make sure things stack up. So I've been involved with a lot of sites more from the energy side, where we've then been trying to use the BMS metering data to help us with obviously diagnosing an issue, diagnosing high consumption. And there's some really simple things you can do to go, no, that's not been set up correctly. So, you know, if you're looking at the sum of the distribution boards in a space, and that one of the distribution boards is actually using twice the amount of what the whole of that building should be using, yeah, that's not right, because that distribution should be using part of what the whole building is using. You know, where you might have 2 lifts on site and one's using 10 times more than the other, you know, potentially there's a decimal place gone wrong there when the engineer's been setting it up. There's been kind of a change or something that's happened. So looking out for these kind of unusual figures, picking them out and actually investigating is really important. And the awful thing about the metering side is it often doesn't get looked at till way after the defects period on the project is gone. You know, it tends to be someone like us that comes in and goes, well, there's a bit of metering here, let's connect it back to your BMS, brilliant, let's have a look at it. And then the client's in a position where they've actually got to perhaps pay money to have an engineer come on site to re-establish the metering. Perhaps things have been installed incorrectly. I've often seen meters where like the wiring's not even connected into the meter, but it looked all right, you know, when they did the handover. And by the way, this isn't a hit out on BEMS engineers. You know, we work with some brilliant guys. It's more about the stress at the end of the project that can cause these things to perhaps get missed and overlooked. So again, you know, trying to pick this stuff up perhaps while you're still in that period, within that kind of first year after the project's been installed, just to make sure that, and you can go back and say, well, it's not quite as we need it. Can you get it re-established? Can you get it working? And they can obviously address that under your warranty. And you can compare this data to your main utility bills. So again, it's not going to be perhaps a perfect match, but if you've got a high consuming site, it's costing you a fortune, you've done your analysis on your bills, you can see that, you can then start to look at the consumption data from the BMS and see if you can pinpoint where it is. You know, it could be that you've got someone's put your chiller in hand and it's been running 24/7 and you've only picked it up because you found it on utility bills. So again, you can start to work these systems together. What I would say is obviously that you would have an alarm in place for that, but you know, that's a perfect situation. So yeah, there's a really big piece about how perhaps the BMS is kind of thought of separately to the energy management in the business, or the energy manager hasn't got access to those tools and information. So that's something, again, where it's really worth connecting the dots to some really valuable stuff in there that could be used to help and improve the overall net zero strategy, carbon reduction, energy reduction, and cost reduction plans. I'm breathed. Dean's turn.
Hey. No, it's grand. Yeah, well, this little section here now is just talking about leading with demand-based control. So when a lot of the strategies are written by the engineers, the guys and girls in the office, or whoever's been writing that strategy, you know, ideally, a lot of the strategies tend to get written to a specification. A lot of the specifications could be quite simply, oh, when the temperature is above this, then do this. But that's great, just to do some kind of standard control. But what a lot of BMS systems or will have, I can pretty much guarantee that most BMS systems will have this type of control available in there. It's just about actually putting it into the software and actually writing that bit in. It could be just dead simple. It could just be missing a few little extra bits here and there that you could just upgrade, or you could reuse your existing BMS controller to do so. It's just the strategy inside of it needs a bit of a tweak. So some of the things that we wanted to talk about was about optimized start-stop control. When I say optimized start-stop control, what I mean is that you take a normal time schedule. So your building starts at 9 in the morning and it goes on till 5 in the afternoon. Pretty standard, 9 till 5. Now, what you'll tend to find with most BMS systems is that they will have optimizers in there. And what an optimizer is that looks at the time you want to start your building. So if you're starting at 9 o'clock, it goes, right, okay, I want to start at 9 o'clock. What it will do is it'll actually look at an extra level as well. And it'll go, right, okay, so you want to start at 9 o'clock in the morning, but also you want to be at 21 degrees or 20 degrees or whatever your building set point is at that same time. So in the settings of the optimizer, what it will do is it will actually go, right, okay, I've noticed that it takes your building this long to get to that temperature for that time of the morning. So what I'm actually going to do is I'm actually going to turn on a little bit earlier. So what that means is then your system then will kick in a little bit earlier in the morning, and then to try and get you to your optimized temperature by 9 o'clock. Now, what you might be thinking there is, well, isn't that costing me more money because my system's starting earlier? Well, no, because what it will do is it will do it on the flip side as well. So what it will also do is it will monitor that optimizer. It will monitor your building's performance over a time period of the day. And what it will actually do is it will actually look at the end of the day as well and go, okay, you need to be you want to be leave by 5 o'clock, or do you want the system shut down by 5 o'clock? And what it will do is it will then notice your system, and it will actually go, hold on here a minute. It actually takes a good few hours in the evening for your building temperature to actually decay and actually go below its set point. So what it will do in the flip side of it is it will turn your system off early as well. So not only am I getting more of an optimized start-stop of the day, but I'm also getting my building to a comfortable temperature for my staff when they come in, for your employees when they come in the morning, to make sure that they're not coming in when the building's just started. Because if they turn in, they've got the coats on, it's cold, they're going to still think it's cold inside your building, when in fact, it's like, no, it's not cold. It's just not got to temperature yet. So optimized start stops is a really good thing, and pretty much all BMS systems will have this form of ability in them. So if you haven't got it already, definitely a question to ask your BMS provider and see if they can provide that for you. Another little thing to jump onto is compensated heating control. Now that purely is down to actually looking at what the outside air temperatures are according to what the internal temperatures are. And then what it will do is it will alter the set point that's being supplied, or the temperature set point that's being supplied to area. So a good example is your radiator circuit. So what it will do is it will look and go, right, if it's warmer outside, I want a lower temperature on my radiators, until you get to the point where you actually just turn it off altogether. But that's economy override, which I'll just jump onto that in a sec. But yeah, the compensated slopes work really well. So the colder it starts creeping up outside, then actually that temperature on your radiator surface will also start increasing as well. And then just to add a little extra onto that, you can also add a bit of room reset in there as well. So that'll go is like, okay, I'm supplying all your radiators with an optimized temperature now according to how hot or cold it is outside. But let's add an extra bit to that. Let's add room reset on there as well. And what that will do is then that will actually look at the temperature within inside the building that it's being supplied at and go, okay, so I want to be 21 degrees in there, and it's currently 19, let's say, or 20 at the moment. So what it will do is it'll go, right, cheers compensated slope. You've done your best to try and get me to where you want. But with the room reset bit, that will actually give you that extra little bit to say, oh, well, actually, just chuck a couple of extra degree on there for me, or actually take a couple of extra degree off. So it does it from both sides. So it's not purely just from outside air. It'll also look at internal as well, or you might just have the one outside. And then the economy override from that point there is just purely then down to, is it higher than 16 degrees, 18 degrees? Now, this is purely dependent on your building and pretty much where you live in the country. Because obviously, like me in the north, we're pretty much cold like all the time. So, you know, our optimizers and our, you know, economy set points are probably a little bit higher than some of us. And all that purely is just saying, look, how hot is it outside? If it goes above 18 degrees outside, then just shut my system down. Turn my boilers off. I don't even want them to run. You know, I've got too hot outside. That's what you tend to find with like compensated heating control, really.
Just to jump in there, Dean, just to kind of make it again tie back into the conversation we had about sensors. So the compensated heating control is based on outside air temperature, which is right. Outside air temperature sensor. Again, that we find sometimes installed in stupid places. So all of that Dean just spoke about, and how integral that sensor is to that whole building, and what it actually kind of starts to do and create from a heat or a cooling perspective, is basically that sensor being installed in the right place and making sure that it's actually working as it should do. Again, we've seen things where it's been mounted in direct sunlight. We find things where they've perhaps been rolled up and stuck in a vent, or they're in the plant room on the top floor of a building, again, in a nice, really warm spot, and they wonder why, why it's absolutely like freezing cold inside, because the sensor thinks it's nice and warm outside. Why would you need so much heat? So yeah, it all interlinks as well, which is why that's so important.
Oh yeah, definitely. Yeah, sorry. Yeah, I forgot to mention that about the outside air sensor. Yeah, of course, get it on that north facing wall. Make sure it's out of that sunlight. I've seen them sometimes where it's been right next to an extract fan from a kitchen, and you know what kitchens are like. They're red hot in there, aren't they? So when that's extracting out, I've seen it in the outside air sensor has been right next to it. Don't get me wrong, some of the stuff they were cooking in there smelled great, by the way, but the outside air sensor was just thinking it was way, way, way too warm for that. So yeah, definitely a good one for that. CO2 air changes, really good one for fans and HVAC systems. It tends to be more for big air handling units, really, this. I said, no, it could be a small air handling unit, sorry, but yeah, more for air handling units. And what this basically will do is it just monitors the return CO2 levels coming from your building. So if you've got a modulating speed control for your HVAC system, then what you can do in this instance is you can go, well, actually, we can save a little bit of money here. Does that fan really need to be spinning around at 100% all the time? Some cases it might do. It might be purely down based to a static air system in your building that has to have so many litres per second provided into those areas, especially with all the COVID stuff going on. That is definitely something that's air changes and things like that are definitely going to be really coming to everyone's forefront soon. But CO2, what you could do in that instance is I did a lot of this in schools and office blocks. So if you find that your CO2 levels are quite high, you tend to find that people get drowsy. People can get a little bit sleepy, you know, in the room, especially in the kids when they're trying to learn, or even just in the office blocks where people are working. So if you've got a system where you're able to monitor your CO2 levels, then what you can do in this instance is slow your speed of your fans down. So if you find that your CO2 levels are being maintained quite well, then what you can do is slow the speed of your fans down, which obviously reduces the amount of airflow entering the building. But in the flip side of it, it's actually saving me a bit of money as well. But just to make sure that those CO2 levels don't then obviously increase again. If they do, then you're monitoring that situation. You can then speed your fans back up again. So that's a good one for CO2 air changes. Pretty obvious one, PIR detection. It's an obvious one, but it gets forgotten about loads. A good little spot to put your PIR detection into is things like toilets. You know, obviously you maintain your air quality in the toilets because obviously you don't want stinky toilets when you walk in there. But it's a really good one, again, if you're able to even slow down the extraction speed of those toilets based on PIR detection. And then eventually, if there's been no PIR detection after a certain period of time, just turn the fan off. It doesn't need to be running, does it really? If there's no one in there, then eventually, and obviously your air quality is being maintained, then yeah, let's turn it off. So PIR detection is great. I mean, PIR detection is brilliant for lighting as well. Lighting in all kind of areas, corridor areas, stairways. Obviously stairways, obviously got to be careful of your security, your health and safety in stairways and stuff. But if you're able to put PIR detection in, then yeah, really, really good. And it's usually really easily adaptable onto systems as well. But again, people forget about it a lot of the time. And then the last one there, Jen, just to finish on, is just a little bit of system feedback control. So the system feedback control is just a little bit more of, well, when your BMS system is making a decision, it sends a signal out and it tells something to do something. But what you tend to find is that the BMS system, unless it really sees those temperature sensors and temperature changes being made, do you really know that the BMS system really know that the signal that it's sent out to actually do something? Like, did it do it? Like, we don't know, did it do it or not? So what you can do with system feedback control is if you, a lot of actuators, and when I was talking about actuators, they're the ones that open and close for your heating or your cooling coils or your radiators. But what you tend to find with a lot of this feedback control is I've sent it a signal to do something. Now I want it to tell me, has it done it? Like, you know, have you actually done what I've told you to do? With that type of information, you can then use that into your demand-based control. So what you can do there in instances, if you get feedback from all of your heating actuators around the building, and all of your heating actuators are saying, I'm all right now, I'm not too bad, I'm only about 5% open. If you've got 20 odd actuators out there and all of them are all telling you that I'm only just a couple of percent open, then really there isn't really demand, is there, for your heating? So what you can then do is then feed that information in your BMS strategy, feed that information back into your boiler control, and actually use that as demand-based control based on valve position. And it's the same for your cooling as well, exactly the same principle. So it's just good. It's actually you've told your system to do something. Then I'm getting that information back from my system then to actually make another final decision to say, do I actually need my boilers to run? Do I need my chillers to run? So it's a really good extra step. Now, a lot of the systems out there can support this. It's again, it just gets forgotten about, but can easily be added back in.
Yeah, I think there's some kind of really good points there. Well, obviously, because we've put the slide deck together, so that's a stupid thing to say. But there are some really good points being made about simple adjustments that make big changes on site. And again, you know, we often see people installing the mystery black box on site that does all this energy stuff, and it's really important. It's, you know, they're quite expensive, but look at the return on investment, and they're being bolted onto systems that actually could do all this for you, cost you a lot less, and you would still get the same output. You know, so like looking after these systems, doing these little tweaks and changes does make a huge difference to that consumption line. You know, also to the performance of your building, how people are actually enjoying being in that space, whether they're customers or colleagues, and really, like, again, these aren't huge things, and the things that have been around a while. You know, this is not us coming up with these brilliant ideas. You know, this is us talking about things that are day to day, should be day to day with these systems.
Absolutely.
So to kind of like round things up, how can you get more out of your existing BMS? So I think that the main message is know where you're starting from and what you've already got. There is no point in investing into your system until you know what you're actually investing in, and if you need to. You know, there could be a lot of this functionality that's at your fingertips, but you haven't realized. There could also be a lot of functionality that you just don't know of within your systems. So again, things like the metering. If somebody hasn't created you a nice fancy graphics page, how do you perhaps know that there is metering on that site? So I think, you know, our recommendation would be to have a good engineer come round, review your systems, talk to you about it, talk to you about what you're looking to achieve and how you might get that, and really get the most out of what you've already got, because it's the most cost-effective way to do it. And often, you know, the project side of the business perhaps isn't as involved with the day-to-day service and maintenance, and that information can be lost between what systems you already have, or we just need to put a new one in. Why, you know, what's the drives behind that, and what should we be doing from that upgrades perspective? You can look at these like easy bolt-on options, like additional sensors, improving sensors. We do a lot with wireless now, adding on wireless things to the BEMS to get that improved performance and energy reduction. And the wireless element means that, you know, perhaps when it was installed, it wasn't feasible to install sensors in the right places, to install certain monitoring kit. But now, with how that wireless technology has come on, and how it's improved, actually, it's a really cost-effective way to do it. And you can get that improved functionality that wasn't viable in the past. Pushing on again with when you're upgrading, know what you're getting versus what you want. Again, we see that so much with these, you know, oh yeah, we've had an upgrade. Well, you haven't really, you know, it looks to you like you've had an upgrade, but you haven't. So getting to know that nuts and bolts. And again, a good engineer on site will be able to tell you what your system is, you know, what age that kit is, what's perhaps easily replaced. If you have an issue, what might actually take 2 weeks to replace, can you afford that going down? You know, they've got all that information, and they should be able to share that with you.
Oh, sorry, Jed, I just wanted to add to that about when you're looking at upgrading, which upgrading is obviously a brilliant thing to do to, you know, future-proof your system, but not just going for a like-for-like kind of, so literally old style controller, new style in place, exactly the same strategy. Because yeah, you've got an upgrade, you know, your controller may continue going now for another 15 years, but it's just literally doing exactly the same thing it was doing before. If you're going to go to the extent of actually upgrading it, then actually go, well, actually, I would actually like to change the strategy that's inside that controller as well, and actually put an energy engineered strategy in place. And that could just be simply adding that demand-based control I was talking about earlier on. So it's all got the capabilities of doing it, but yeah, just try and get as much out of it as you can.
And especially with COVID, people they're not using the buildings as they were even like 18 months ago, 2 years ago. So why would you want to perhaps put in the same system that actually might not now be fit for purpose? But we had a client a couple of weeks ago when they were on site, and they'd had a trend system. I think it was an IQ2 that had been replaced with an IQ4, like for like. And the client was talking to us about actually something that's been an ongoing issue. They wanted to bring it to the BMS. Now, because it had been done like for like, there was no additional IO spare on the controllers. They hadn't perhaps spoke to the client about future proofing and having some spare capacity there for what they wanted to achieve. So ultimately, it's now going to cost them quite a lot more than it would have been just to have up-spec that controller that was being replaced to allow for that additional IO. So it can be things as simple as that. And you're talking potentially thousands of pounds saving here on these tiny little things that are going on your buildings. So the general message is, speak to a specialist who can look at the whole piece altogether. They're not going in and just looking at a tiny element of it or just working through a pre-designed PPM schedule. They're looking at what you're trying to achieve, how you can achieve it, what your systems can do, what functionality is there already, and really give you the best advice as to how you can then take future steps to get where you need with these buildings, whether it's improved comfort, improved energy management, carbon reduction, you're on your path to net zero. The BEMS is a really good place to start with that. So a little bit of a plug for our academy here.
This is where I am right now.
Yeah, that in there is the Thermatic Training Academy. It's where we trial out new technologies, training with our partners, our customers use the facilities training, and we also do from an energy management perspective. We're really open to engaging with people and utilising the space. We do a lot with local colleges and education, and again, it all ties into that journey of us educating, sharing systems that we work with, how they can operate, and again, trying to help people make those informed decisions. So, can have a little breath now, and see if there's, I suppose, any questions. I think we covered a lot there. Hopefully, you can see that we are a passionate bunch. We do love what we do. We often talk about it a little bit too much, but our aim is to just, I suppose, create that excitement and and make people see the benefits and potential for these systems. So hopefully you will join us for our next edition of Decoding the Industry, and even potentially suggest some of the areas you'd like us to look into. Sean, are you there?
Yes, thank you so much, Jen and Dean, and thank you everyone for joining. If you have any questions, do drop them in the chat function now. I've got a couple here. Can you combine BMS metering data with utility bills?
Utility bill data, yes, you can. You can't use it from, well, depending on what meters have actually been put in. You would have to see if they were correctly verified and installed to actually be able to bill from them if you were looking at tenant billing and things like that. But actually comparing them to what you're spending at the top level, so looking at your main consumption, yeah, 100%. If you can see what your main electric meter is doing, and then you can see actually in the BMS that you had your lighting was doing X, your chillers were doing this, your AHUs were pulling that, you can start to then level out if there's any major issues in that area, and go from there. So yeah, I would definitely say the best thing to do though is to make sure that you've got half-hourly data coming through, do that storing exercise and logging exercise to make sure it's the right kind of information, and then yeah, there's no reason why you couldn't use that as part of your bigger energy management strategy.
Sorry guys, you've just seen me moving around there a little bit. The battery on my laptop was just about dead, so I've just come over here a bit.
That's not very resilient, Dean. That's not what you always talk about.
So I was trying to save energy. I thought I'd use my battery properly.
I suppose that leads on nicely on that case to what is the best BMS?
Oh, the best BMS. Now, I could be cruel or I could be kind. Now, everybody's got the favorites. Everybody's got the favorites. Now, I'm not gonna lie. I've got some favorites. I really like Trend. I really like Tritium. I've spent many years working with Siemens as well. There's a couple of other bespoke ones like Preva and Delta out there. But ideally, they're all the same, really. You know, they all kind of do the same thing. Everybody prefers the way that one work. Like if you ask a load of BMS engineers, a lot of their favoritism tends to be due down to the type of program, the programmability of the controllers. Now that could be anything from logic-based control, where it's looking at actual physical logics on a strategy page and they're all linked together with lines, or it could be that some people's favorites are very line-based control. So that could be more like, oh, if this, then do that, else do this type of coding. But the best system out there, well, I really want. I really can't pinpoint it down to one of them, because I do genuinely like. I know that's kind of like sat on the fence kind of answer, but I do genuinely like working with many different systems, really.
I think some of that is worth mentioning. There is Dean said, you know, everyone has their preferences, and I think providers do as well. You know, people often say, you know, oh, I've got a trend, and they don't mean they've got a trend BMS. They mean they've just got a BMS. It's the BMS system. It might not even be trend, because that's kind of like quite a household name. But often people don't, like companies like ourselves, you know, we've got affiliations with certain controls manufacturers. Others will perhaps have different ones. So it's really worth talking to a couple of different people about the models and manufacturers of what's out there, because it does really come down to what's going to be best fit for the project that you're doing. And what's going to kind of sit budget wise as well. There's some great lower cost controllers that we will use with our clients if it's the right solution. That perhaps, again, if they'd have been looking at some of the other manufacturers, there would have been no return on investment on that project within the time they want to look at. So it's just all about horses for courses, making sure that the BMS system fits.
Yeah, as long as it fits and it works for you, then that's got to be the best one for you.
Yeah.
And if before anybody asks a question, I do look a little bit more tanned in this video than now compared to, but I've been sat under this Ambirad heater for quite some time now, so I think I've been getting. I don't know if anybody can see that. That's just some of the it's a big heater, that, but that's just some of the stuff that we have got here in the academy, where we've got our mechanical gear in here, we've got our controls equipment in here as well. It's a great little space just to come in, have a play, just get to know some of the systems, especially for the engineers that are out there working on them. So it just gives them a lot more hands-on experience. So I do quite like this area. Just being a bit of a geek, I do like all of this stuff. Just have a play with and that. But that's where I am. But my knees are giving away there a little bit.
I was going to say we were thinking that we'd probably been about half an hour, and we're topping an hour here nearly now. But because we've obviously gone through a lot of different areas. But yeah, you know, hopefully that's been of interest, and we've kind of covered off some topics. And like I say, if you're watching this live or you're going to be watching it on a recording, you know, feel free to get in touch with us and follow up any queries and questions you've got. We're quite open and honest about, you know, what we'd recommend. You know, even if that means that actually your system's brilliant as it is, you don't need to do anything with it. You know, we'll be fair with that and make sure that, again, we can just be here for support and advice.
Nice one.
Brilliant. Right.
Really, well, thank you everybody for your time, and yeah, no, I look forward to seeing you all at another one.
Thank you very much, everyone.
Cheers. Take it easy.